This is an AS FP2 question on reducing a matrix to diagonal form. We've got a matrix here with elements 1, 1, negative 2, 4. The question is asking us to find a matrix P and a diagonal matrix D such that D is equal to P inverse AP. So the first thing we need to do is to form and solve the characteristic equation. Now remember, the characteristic equation is the determinant of this matrix, A minus lambda I, the identity, is equal to 0. So the whole of the A minus lambda I is going to look like this. We don't need to write that out. You can probably do it in your head. So let's write down the determinant. So we've got 1 minus lambda as the first element. Then the second one is going to be 1 minus 0, so it's just going to be 1. Down here we'll have negative 2 minus 0, so just negative 2. And then 4 minus lambda. So from here, so that's going to be equal to 0, we'll find the determinant. So that's going to be 1, so it's AD minus BC. So 1 minus lambda times by 4 minus lambda minus, that's the AD bit, minus BC, so minus 1 times by negative 2 is equal to 0. Let's multiply that all out and see what we get. So multiplying out the first sets of brackets, I'll get 4 minus lambda minus 4 lambda plus lambda squared. And then from here, so 1 times by negative 2 is negative 2, and we're subtracting that, so it becomes plus 2 is equal to 0. So that will give me this quadratic, lambda squared minus 5 lambda plus 6 is equal to 0. So that's an easy enough quadratic to solve, I think, because that would factorize to give me lambda minus 2 and lambda minus 3. So my two values of lambda are 2 and I've got lambda equals 3. So these are the eigenvalues of the matrix A. So I'll just write that down. So what I need to do now is to work out what the eigenvectors are associated with each of the eigenvalues. So let's start with lambda is equal to 2. So it's going to be our matrix A, 1, 1, negative 2, 4. And we're trying to find a matrix that when we multiply it by A, it's 2 times this matrix XY, or this vector. So we're now going to solve this. So from the top row, if I multiply it out, so I'll get x plus y is equal to 2x. X plus y is equal to 2x. And then from the bottom row, I will get negative 2x plus 4y is equal to 2y. So the top equation is just going to give me that x is equal to y if I subtract y from both sides. And from the bottom equation, if I, let's see, move the 2x across to make it positive 2x, and then take away 2y from both sides, I basically end up with an equivalent equation there. So I end up with 2x is equal to 2y, or minus 2x is equal to minus 2y. So a eigenvector, because obviously there are lots to choose from, where x is equal to y is going to be 1, 1. So for my value of lambda equal to 2, my eigenvalue, I get an eigenvector of 1, 1. Okay, so let's now do the same thing, but with the other eigenvalue of 3. Okay, so rather than write all of the working out, I'll just change the numbers. So this is going to be 3 here. Obviously, it's going to give me slightly different equations. So let's see what we get from that. So from the top one, I will get x plus y is equal to 3x. So I guess from that, if I take x away from both sides, I've got 2x is equal to y. And then from the bottom row, I'll get negative 2x plus 4y is equal to 3y. So from this, I will get negative 2x again is equal to negative y. So same equation. An eigenvalue that I could choose would be, let's say, if I made x equal to 1, then y would be 2. So 1, 2 is an example of an eigenvector. So any linear multiple of that would be fine. So when lambda is 3, that gives me an eigenvector of 1, 2. Okay, now we're almost done. Now remember D, that vector is formed by the eigenvalues. They go along the diagonal. So 2 and 3. And then P is made from the eigenvectors. Now these need to be in the same order as the eigenvalues. So 2 was the vector 1, 1. So 1, 1. And the eigenvalue of 3 was the vector 1, 2. So there we go. This is one of many possible solutions because I chose particular eigen vectors. I could have chosen any multiples of those. And also I've put my eigenvalues with the 2 in the first column and the 3 in the second. It can be the other way around, but then your vectors here would also be the other way around.